Hello friends, today I will discuss something on mod function. It is very important for the students as they are going to class 11 from class 10. Let's start. Fx equal to mod x. Now what is mod x? Mod x means magnitude of x. Now how can you understand this one? Suppose mod of minus 2. Now we know that magnitude of minus 2 is 2. Therefore, it is equal to 2. Suppose it is mod of minus 5. We know that magnitude of minus 5 is 5. So it is 5. Suppose mod 3. Now magnitude of 3 is 3 itself. So it is 3. Therefore, mod x denotes the magnitude of x. Now using that property, I can define mod x formally, that is mod x equal to x when x positive, mod x equal to minus x when x negative, and mod x equal to 0 when x equal to 0. So it is very important. Now why this one happens? In the first part, if I say that mod x equal to x when x positive, now we know that when x is positive, then magnitude of x is x itself. Just like magnitude of 2 is 2. Therefore, in that case, we will get mod x equal to x when x is positive, then magnitude of x is x itself. Just like magnitude of 2 is 2. Therefore, when x is positive, then mod x equal to x. Now, in the next case, mod x equal to minus x when x negative. If x is negative, then magnitude of x is minus x. Why? Suppose x equal to minus 2. Then what is the magnitude of x? The magnitude of x is plus 2. Magnitude of x is plus 2. Now how can I get plus 2 from minus 2? Plus 2 equal to minus of minus 2. Therefore, when x is negative, then the magnitude of x is minus x. So we have defined mod x equal to minus x when x negative. And the next one, mod x equal to 0 when x equal to 0. So we have got the definition, that is mod x equal to x when x positive, mod x equal to minus x when x negative, and mod x equal to 0 when x equal to 0. Now, number 1, mod x equal to mod of minus x. Why this one happened? Because the magnitude of x and magnitude of minus x are same. Magnitude of x and magnitude of minus x are same. Therefore, mod x equal to mod of minus x. Just like mod 2 equal to mod of minus 2. Next, number 2, mod of xy equal to mod x into mod y. That means magnitude of xy equal to magnitude of x into magnitude of y. Similarly, number 3, mod of x by y equal to mod x by mod y. So at first I have to know all these 3 properties. That properties are basic. Number 1, mod x equal to mod of minus x. Number 2, mod of xy equal to mod x into mod y. Number 3, mod of x by y equal to mod x by mod y. Now, I will discuss a very important topic, which is root over of x square equal to mod x. It is very important to solve several problems that comes in IIT JEE as well as in ISI. But what is the general form of that expression? The general expression is x to the power 2k to the power 1 by 2k equal to mod x. So this is the general form, that is x to the power 2k to the power 1 by 2k equal to mod x, or 2k x to the power 2k equal to mod x. Now question is that how can I define or how can I prove that thing? Look at here, x to the power 2k is greater than 0 or equal to 0 when x equal to 0. Considering x not equal to 0, x to the power 2k greater than 0. Now, mod of x to the power 2k equal to x to the power 2k. As we know, mod x equal to x when x is positive. And that line gives us x into x into x up to 2k terms equal to x to the power 2k, and that gives us mod x into mod x into mod x mod x 2k terms. Why this one happened? Because mod of xy equal to mod x into mod y. Therefore, x into x into x into up to 2k terms equal to mod x into mod x into mod x into mod x up to 2k terms. It is equal to x to the power 2k. Now, mod x to the power 2k is equal to x to the power 2k. Therefore, that implies x to the power 2k whole to the power 1 by 2k equal to mod x to the power 2k whole to the power 1 by 2k, and that is equal to simply mod x. So what I have proved? X to the power 2k to the power 1 by 2k equal to mod x. Now following that matter, when k equal to 1, then in that case we can get this one also, that is 4th root of x to the power 4 equal to mod x, and so on. So we have proved this one, that is root over of x square equal to mod x, and that will come from the general term, that is any even roots of x to the power 2k is always mod x. Till now, what we have got? We have got nth root of x to the power n equal to mod x when n is even, and it is equal to only x when n is odd. So it is very important for all types of examinations. Now, suppose we have to solve a question which is root over of x square plus cube root of x cube plus 4th root of x to the power 4 plus 5 root of x to the power 5 when x is negative. So we have to find its value when x is negative. Now how can I do this problem? First one, 2 is even, so it is mod x as per definition. Here n is odd, the 3, so it is only x. It is 4, again even, so mod x. It is 5, odd, so x. Now it is mentioned that x is negative. As x is negative, therefore mod x equal to minus x plus x minus x plus x, and it is 0. Hence the value of root over of x square plus cube root of x cube plus 4th root of x to the power 4 plus 5 root of x to the power 5 is equal to 0 when x is negative. Now I am coming to the next portion where I have to prove an inequality which is called as triangle inequality, that is mod of x plus y less than equal to mod x plus mod y. Now how can I prove this one? First of all, we know that mod of x plus y whole square. Now I have to prove an inequality which is very important, and that is called the triangle inequality. That is mod of x plus y less than equal to mod x plus mod y. How can we prove this? We know that mod of xy is greater than equal to xy. Because mod of xy is always positive, but xy can be negative. When xy is positive, then mod of xy equal to xy, and when xy is negative, then definitely mod of xy is more than xy. Now, mod x into mod y more than equal to xy. So 2 into mod x into mod y more than equal to 2 into xy. Now, if we add x square plus y square in both sides, then we will get mod x square plus mod y square plus 2 into mod x into mod y greater than equal to x plus y whole square, because x square equal to mod x square, as x square is positive, so mod of x square equal to x square, and mod of x square equal to mod x into mod x squared, so mod x square equal to x square. Therefore it is mod x square plus mod y square plus 2 into mod x into mod y greater than equal to x plus y whole square. Now that means mod x plus mod y whole square is greater than equal to x plus y whole square. So definitely the magnitude of mod x plus mod y is more than the magnitude of x plus y. So whole mod x plus mod y more than equal to mod of x plus y. What I have said, the magnitude of mod x plus mod y is more than the magnitude of x plus y. Now we know that mod x plus mod y is positive, therefore it is equal to only mod x plus mod y. So we have proved mod x plus mod y is more than equal to x plus y. Now question is that how can we get that equality? How can I get that equality? To find the equality condition, we have to look into the first step. The first step is mod of xy greater than equal to xy. So mod of xy equal to xy when xy is positive. So when xy is positive, then mod of xy equal to xy. In that case, mod x into mod y equal to xy. 2 into mod x into mod y equal to xy when xy is positive. Similarly, equality holds in all these steps when xy is positive. Therefore, mod x plus mod y equal to mod of x plus y when xy is positive. So it is very important. You can get so many problems from that topic. Now, suppose you are given mod of x minus 2 plus mod of x minus 3 equal to 1, and you have to find the values of x. You have to find the values of x. Now, how can you do that problem? We know that mod x equal to mod of minus x. Therefore, mod of x minus 2 plus mod of 3 minus x equal to 1, because mod of x minus 3 equal to mod of 3 minus x. Now, this mod of x minus 2 plus mod of 3 minus x more than equal to whole mod x minus 2 plus 3 minus x. Because mod x plus mod y more than equal to mod of x plus y. Hence, we'll get it is 1. Therefore, in that case, equality holds. In that case, mod of x minus 2 plus mod of 3 minus x equal to this, as it is equal to 1. And when equality holds, then definitely what I have mentioned, that x into y is positive. Here x is x minus 2 and y is 3 minus x. So, if equality holds, then x minus 2 into 3 minus x is positive. And if x minus 2 into 3 minus x is positive, then definitely x minus 2 into x minus 3 is negative. And when x minus 2 into x minus 3 is negative, then definitely x lies between 2 and 3. Now, one question, that is, that equality also holds when xy is 0. That equality also holds when xy is 0. So overall, equality holds when xy is non-negative. So that equality also holds when xy is 0. Now in that case, I have considered that it is more than 0, but I have to write it is more than equal to 0. So it is less than equal to 0. So here, this one. Therefore, the solution of this equation is x more than equal to 2, less than equal to 3. Okay.